Hey, what's up, everybody? Welcome back to my channel. We're going to talk about pointers. We're going to keep talking about pointers. Pointers all day, baby. Thank you for taking my advanced programming concepts course using C++. And what I'm going to talk about with this lecture is we're going to build upon our knowledge that we've been building over a couple of lectures that I posted. And we're actually going to get more in the weeds and talk about functions, comparisons, dynamic allocation, and all that good stuff. So let's get started. So if we look at this program here, one thing that I did want to point out is that it is a good idea to initialize your pointer variables so that the compiler knows that you're pointing to some invalid memory address. So in this case, what I'm doing is I am initializing my pointer int to null pointer. So that tells the compiler that it's not pointing anywhere, it's an invalid memory address. And now I can reassign it to a valid variable. So what I can do, what is that? What does this give me, right? So what I can do is that if I had some code in between, or I was using a function and I was trying to test the validity of this pointer, I can say if pointer int is not equal to null pointer, I can now say, okay, let's point it to my numbers array, and then maybe we can just print out something like that. So by me actually initializing null pointer variable to null pointer, I'm able to compare and see if it is null. And if it is null, then I can assign it, because maybe you may have a situation where you have a couple of pointers happening in your program, and perhaps you don't want to reassign the pointer anywhere. That's a first. Sorry about that. I hate it when that happens. I'm not going to stop the video, so I'm just going to keep going. So we have the ability now to compare our pointers to something that's null, and that allows us to check if it is a valid assignable pointer address variable. If you had another pointer or another variable that you're assigning this to, and you don't want to reassign it, then this is a good way to check if it is actually null or it's not. Meaning you want to make sure that when you are assigning a pointer, it is clean. Now, let's talk about comparisons. Okay, so actually, let me run this first. I hate when these scam likelies interrupt. Let's do this. What is going on here? Why is this not showing anything? Okay, so if we have a variable that we are trying to compare, so we'll pointer variable, we know that this is a pointer to an int, and we made it point to the initial address, the starting address of numbers, right? Now, let's say I want to compare, the first and then the last element. So the way that you can do this is you can say if pointer int is greater than, we're going to do the dereferencing here, pointer int plus. So remember, we add on addresses, so 1, 2, 3, 4. Let's do this. It's less than. We can say cout initial value is less than fourth element. So by doing, now this is weird syntax, but you can compare values by just dereferencing the variable, and then I want to skip 4 elements and then dereference that as well. So if I do that, you can see that initial value. So basically what I'm doing is I'm comparing the initial value, which is 5. Is 5 less than this 30 here? And it is, so I get this printed out. Now you have to be careful that this does not mean the same thing as that. Okay, if you do that, that means you are comparing the address. Okay, and that's always going to be this is always going to be true because this is on a lower address than point ptr int plus 4, because remember they are sequential and they're going up. So from here all the way up to here, you're never going to have a situation where your addresses are going to go down. I hope I am right, but yeah. So this address is always going to be less than ptrint plus 4. So just make sure that you are aware of that. Okay, you are aware of that. So, and then you can also do, you can also compare your array itself, okay, using the ampersand. So if I did numbers, right? I guess it doesn't let me do that. Oh, because it's not a pointer. Oh, you know what I can do? I can do that. That's also going to be true, right? So that's why you have initial value. I mean, this message doesn't mean anything, but so many ways you can compare. I'm not sure why you would want to compare addresses, but there could be a use case where you would need to compare the address of an array. Usually what we want to do is we want to stay with the dereferencing operator, the indirection, and then just compare our values. Okay, where we want to compare the contents of what it's pointing at to the contents of where I want to check. So we can use the relational operators with pointers, so that is a fact. We can do that. Whenever you find yourself in a situation where you have to do comparisons, just make sure that you do use the indirection operator so that you can compare the values and the contents. I don't see any situation, at least in my opinion, I've never ran into a situation, unless you're dealing with microcontrollers or trying to allocate memory in a very meticulous way, where you want to compare the addresses of arrays. Okay. Okay. Now let's talk about the passing a pointer to a function. Okay, what the hell that means. All right. So let's write a quick function here. I'm going to write a quick function. We're going to call this void double value. Okay. Okay. So, and then I am going to write this here. And all I'm doing with this is I'm going to say that val, just going to double the value. Okay. So when I pass a pointer to a function, it's actually doing the same thing as if you were passing a value by reference. I mean, a variable by reference, not a value, but a variable by reference. So when you pass in your variable into this double value function, it's actually passing it in by reference, meaning that it's going to get changed. So let's take a look real quick, okay? So let's do this. Okay. If I say int some value is equal to 10, and then double value, and then I pass in some value, right? If I do that, okay, because I'm passing a pointer, okay, because I'm passing a pointer, I need to pass in the address of my variable, because the parameter itself is indicating that this is a pointer. And what that means is that you're passing in the address, meaning that it's going to reference the variable that you're passing in. So I'm going to pass that in with a reference parameter, and then you'll see now that my value is going to change. Did some value change? And we can say some value. So let's take a look. So there you go, right? we saw that when I'm in the main function, I'm passing this because this requires a pointer, right? It's actually just saying, hey, I need the address. That's all I need. Okay, I just need the address. That's really all I'm looking for, at least my function. And the function itself is now going to take the reference of that variable and then do whatever it needs to do. In this case, we're multiplying it by 2. Always remember that we got a dereference, right? So that we change the value, and then we also can read the value using the dereferencing operator. Okay, and then this is definitely going to change the value because we are assigning it to the indirection operator with the val, and we saw in previous videos that that's how we change the value of a variable, the contents of a variable. Okay, so pointers as function arguments can work as replacements for using the pass by reference operator, which is the ampersand. Okay. Now, why would this is a bit very confusing, I would think, right? So why would you want to use that? You want to use that because there are functions that are pre-built in C and C++ that are going to require you to understand that the parameter itself is a pointer, which means it's going to be passed by reference. Okay, so I'm not teaching you this because it's fun or I feel like it's so cool to learn. You're going to find a lot of functions are going to require you to pass in a variable that's passed by reference, and some functions will require pointers, okay, in terms of the function parameter. So it's good for you to understand this. Now, let's we can now if I do that, right? If I pass that in, I can also pass in a array. Okay, so if I pass in my array, if I do that, right, this pointer is actually just going to point to the first element, right? So what I'm doing is I'm multiplying the first element times 2, right? So 5 times 2. And then I can do numbers of 0. And you're going to see that this is actually going to change from 5 to 10. Okay, because we're pointing to the array, and it always is going to point to the first element of the array. And we're just going to multiply that element times 2, replace that value in a 0th index, and then we should have 10, right? So I think it's easier if I show you what's actually happening here with the array. Okay, so let me do this real quick. I'm going to get rid of this. This is initialization. Okay. I'm just going to take this, and we are going to go into my drawing world. All right, so we have this array, right? And now we understand that if this numbers array, referencing just the variable itself, it's actually referencing the address, right? So x01, x02, x03, x04, and x05. This function, right, is as a parameter, it's actually requiring a variable where I can point to. So anything that comes in has to be it's got to be an integer type, because that's the only thing I can point to, right? So if it's an integer type, I can pass in my numbers array, right? So what is the initial starting address of numbers? Okay, the initial starting address is x01. So what that means is that val, the contents of val, is x01, right? When it comes in here, right? So once I make that function call, Now val becomes x01, which means that this is now pointing to my numbers array. What is the contents of val? The contents of val is going to be 5. And when I say contents, I mean the indirection operator, dereferencing, right? So this is star val, and this is val, right? So, and again, it always points to the initial one, right? So now, when I get over here, it's doing dereferencing of val, which is 5, right? So the dereferencing of val represents 5, and I'm multiplying that by 2, right? And that gives you 10, which at the same time I'm assigning it to the contents of, right? So I am going to take this value out and then do that. Okay, I could have easily done the following. I could have actually said, if I wanted to replace this value, right, I could have said star then val plus 1 is equal to, right, and then star val val, let's just do times 3. So by me doing that, I would actually have replaced this thing here, because now I'm adding 1 to the address, right? So x01 plus 1, right? So let's take a look. I'm just going to show you real quick, okay? So logically, what I can do is I can say that, right? And then I'm going to multiply it by 3, right? So I'm taking val, which is the initial address, so 5 times 3. And then I'm going to replace this because I'm just doing it so I can show you. So we're going to print out whatever is in index 1, right? So if we do that, you see that it got changed. So I can use this notation with my dereferencing operator to replace values. Okay, I didn't necessarily have to do it just with val. I could have done it with val plus 1, val plus 2. And what that buys me is now I can, again, because of this pointer, I can pass in I can pass in a simple variable, as we saw initially, or I can pass in an array. And it's really, the array, it's really only getting me the initial address of the array, which means that now I can access the other addresses. Now, there's a problem here, okay? If you decide to create a function that has a pointer as a parameter, an integer pointer, and you decide to pass it in an array, the problem is that you really don't have a limitation. So I don't know when this array is going to end, at least in my function here. So what size is my array? If I decide to, right? Is my array. So the couple of things you need to think about when you write a function that has a pointer is, if you plan on passing an array or allowing the user to pass an array, you should pass in the size of the whatever is coming in. So in this case, maybe the size is 5. So I would have an extra parameter, because what's stopping me from saying val plus 8 equals blah 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 blah? It's not really stopping me, right? What's going to happen is the compiler is probably going to it's going to choke, or it's going to give me some unexpected results because I'm writing over memory that does not belong to me. Okay, so you have to be careful. You have to be careful when you're using pointers as parameters. Okay? So it's best, if you know that you're passing in an array, you may want to pass in the size. So I'd have something like in size here, and then that can indicate that I cannot go over that size. Okay, cool. So on the next video, I'm actually going to talk about dynamic memory allocation, and hopefully that should wrap everything up in terms of pointers. You should have enough to just be a little bit dangerous. I'll see you on the next video.